Hi all, this is Mr. Yeager, continuing on with our initial kind of introductory unit for physical science. We're moving on to experiments. This is kind of expanding our prior video on scientific method, where obviously experimentation is part of the scientific method, but this is going to help us kind of identify what we need to look at, the variables and the controls and the constants that we need to take care of in order to create a good experiment. So here we go. Okay, that up there, there we go. All right, so with experiments again is the actual action of observing and collecting the data that you're going to use to then determine whether your hypothesis is correct. Remember, we identify a problem, we develop a hypothesis, an inference of why this is happening, and then we actually test it, right? And then we collect that data, analyze, conclude, etc., etc. So again, this is the actual development of what are we going to test and how are we going to test it. So I like this diagram because it talks about basically the idea of, cause and effect and so forth. Basically that's what we're looking at. They have it right underneath of it. We're going to be looking at what are called the independent and dependent variables, because in an experiment we usually only want to test two things, how one thing affects another and see what the outcome is. Obviously though, we're going to have to take into account that there might be multiple things that can affect an experiment, and that we never use the term confounding. That's something that we never use. But it would be the idea of these other variables could affect the outcome, so what do we need to do to make sure that they don't cause any change with it, okay? So that's what we're basically looking at in this particular case, okay? So again, important terms coming out: variables, controls, and constant. Variables is our cause and effect. The controls and constants would be our other factors that we have to take into account when we have an experiment. Okay? So, what is a variable? So I basically have some questions for you, like what can make a plant grow? Maybe that's our problem. I want to make a plant grow. So what can help a plant grow? We'd be sitting there going, well, sunlight, fertilizer, water, and things like that. So the thing is, if all of those things affect it, which one are we going to actually test? And we only want to make sure we test one at a time. Again, with the outcome being plant growth. What do we need for a good night's sleep? All right? Is it the time? Is it time we go to bed? The amount of sleep? The amount of quality sleep? The amount of what are we eating beforehand? What are we exercising? I mean, there's all sorts of things that can lead to a good night's sleep. Okay? So what do these things depend on? What can change or affect the outcome of the questions above? That's what we're basically doing. We're identifying the variables, the things that can change and affect these outcomes of plant growth and good night's sleep. Okay? So, again, variables are what we change. We're only ever going to have two variables in an experiment. Okay? And that's because we want to be clear, we know exactly what affects the outcome. If we miss something, if we realize, hey, this could affect the outcome, we need to go back and do the experiment again and try to keep that still. Okay? Keep that the same and see what happens. All right? Or we change up and go, okay, let's keep this other thing that we've been changing constant and change this other thing to see if it affects the outcome. Okay? So again, we want to make it clear, all right, the whole idea of the two variables is to make it clear what is causing the change, or maybe not causing any change. I mean, that's the other thing to be aware of. Sometimes we test something and it doesn't affect it. That's a good experiment. You figured out something that doesn't affect the outcome. Okay? So it could be multiple things. So the two types of variables we run into are dependent and independent. Okay, sorry, trying to make this come up. And independent. Okay? So the dependent variable is, again, what are you trying to affect? Like, basically, what is the problem? I mean, what are you trying to determine from it? And then the independent variable is what you are going to alter to see if it affects that outcome, to see if it affects the dependent variable. So a lot of times, I mean, it's silly, we say dependent depends on independent. Okay? The outcome depends on the effect. All right? So again, dependent is what occurs after independent, physically change the something during the experiment. So with plant growth, that would be my dependent variable. Maybe my independent variable would be fertilizer type. Like what type of fertilizer you're giving. Type of fertilizer. Maybe one fertilizer works better than another based on the type of plant you have. It could be A separate one, so if we didn't do that one, maybe it would be sunlight. How much sunlight is it getting every single hour? Okay, et cetera, et cetera. So that's something that you can affect, which then can cause a change in plant growth. Okay, so independent causes a change in dependent. From there, now we know what we're trying to manipulate. We need to identify things that we're going to try to keep the same. But we also have another thing called the control. And I know from prior classes even that I've taken in science, this has not always been given correctly in terms of the correct definition for it. A control, as I write at the top there, is a standard for a comparison. It's what we sometimes call, and I mean you don't need to remember this specifically, as a null test. What that means is a nothing test. Null means nothing. What it basically means is where you do an initial test without using what you're about to change, your independent variable. Okay, the zero test. So if I said I'm going to test how each type of fertilizer affects plant growth, I would do one plant with no fertilizer. All right, with no fertilizer whatsoever. This would be my control. All right. And then you do that because we want to see whether the fertilizer actually has an effect. All right. One classic one that I generally use. Actually, let's wait a minute. Okay. Sorry. So yeah, I mean the one I have here is if I said water affects plant growth, what would you do? You do a test where you don't use any water. Okay. But another classic one that I feel like I often try to say with students in class is I go, let's say I want to wash clothes, okay, in a washer, and I want to use different types of detergents. The thing is, if I throw the clothes in the washer with any detergent, they will get cleaner. They won't maybe get super clean, but they should get cleaner. Why? Because the washer has water in it. It has the temperature of the water, which would affect it. It has obviously the motion, the grinding, the grinding motion of the machine, rubbing the clothes together and rubbing against the sides. All that's going to affect trying to clean the clothes. Then I throw detergent in and clean the clothes again. Try to make them obviously equally dirty. Clean them again and see what happens. There's times where you might realize that, hey, this detergent does nothing. You just wasted your money. And I mean, that's the whole idea of like placebos and things like that. It's a test just to see what you think you're going to feel like is going to happen versus what actually happens. So it's almost like a placebo. It's the controls for biology is a placebo group. The other thing we would look at are constants. So these are the other things that we would keep the same. So this is not a standard comparison. These are things that could affect the outcome, like I said with the washer. The amount of water, the temperature of the water, the cycle, you'd have to keep all of those constants so they don't change the outcome. Okay? So if we're growing the plants and stuff, you want to see how amount of water affects the growth of a plant. Our independent variable is amounts of water. Our dependent variable is growth of plant. What would be constants? Constants would be what else could affect the plant growth? Sunlight, fertilizer, etc. Type of soil. Okay? We have to keep all of that constant. Even the type of plant. Clearly you got to make sure you have the same type of plant. There's certain plants that just grow better without water versus others. All right? So those would be your constants written down there. Okay? Sorry. All right. So in the end, and we're going to do a couple of these together, what you're trying to do with most experiments is go, what is the independent and what's the dependent variable? What are you trying to affect? What are you changing? Okay? Get those first. The control would be the zero formula, the zero experiment essentially, and then constants would be anything that you basically keep the same. All right? So then we're going to practice some. Okay, let's go here. Let's do a couple practice ones. Okay, so I'm only doing a few here, but let's just identify independent and dependent variables real quick here. All right. Oops, sorry, I just messed something up there. Sorry. All right, so sorry, back to that. So let's just do a couple of these and go, what's the independent and dependent variable? We might also look at some controls and constants as well. So number one, the time it takes to run a kilometer depends on the amount of exercise the person gets. Okay? So the nice thing is this has a clear word trying to tell you what's happening. Time to run depends on amount of exercise. So that means the time to run must be my dependent variable. The amount of exercise would be the independent variable. What would be a possible control? Basically see how long it takes the time to run with no exercise. Okay, that would be one there too. Oop, I don't know how to spell exercise, sorry. Exercise, there we go, I got it. All right, the amount of time to exercise. All right, what would be constants? Maybe what are you eating beforehand? What are you drinking beforehand? The type of exercise, and things like that. The higher the temperature of water, the faster an egg will cook. All right, the higher the temperature of the water, the faster an egg will cook. I can see here that the temperature will affect the time to cook, basically time to cook. So this is the independent, the temperature is what I will affect, and the time to cook it would be the dependent variable. Constants, amount of water, type of egg, type of, etc. like that. An investigation was done to see if, I'm only going to do like two more. An investigation was done to see if keeping the light on for different amounts of time each day affected the number of eggs chickens laid. All right, this one again has that nice word affected, which means anything after it must be the dependent variable. So the number of eggs is dependent, amount of time each day in the light is the independent variable. So sometimes they give you that nice clear wording where you can go, this is affecting something else. Independent affects dependent. What would be, a control, I guess, would be making that chicken sit in the dark and see how many eggs it lays. That would be technically a control because that would be the light, no light. Okay. We'll do one more. The temperature of the water was measured at different depths of a lake. The temperature of the water was measured at different depths of a lake. Okay. This one's a little bit tougher. I would say the independent is the depth, with the dependent being the temperature. The temperature depended on the depth. Okay, depended on the depth. It's not like temperature affects depth. Depth affected the temperature of the water. So that's what we're basically looking at in creating experiments. Independent, dependent. Independent is what I change. Dependent is what gets affected afterwards. We got controls. Those are the non-independent variable, like no independent variable tests. Constant things that we keep the same, and that's how we do all of our experiments. All right, that's it. Thank you.